Hello guys, welcome to my YouTube channel of Debneel's Mathematics Desk. So as you can see, today's video is dedicated to the students of class 8. Before starting the video, a huge thanks to all of you for the support you have shown to my channel till now. Like you have shown support to my channel, please keep supporting it and keep liking, sharing and subscribing my channel. It means a lot to me. So then, in the previous video for class 8, I had explained sets part 1, the two types of representation of sets, which were roster method and set builder method, and I also explained what is cardinal number of sets, which means the number of elements in a set. We did a lot of sums and understood all the topics actually carefully. So in today's video, as you can see, it is part 2 of this chapter. It's a long chapter actually, and the topic is types of sets. So today we will come across different types of sets, learn their definitions and solve lots of sums on them. So then, without wasting much more time, let's get into our video. Let us see what we have. Alright. First one, let me write a question for you first. Question 1. A set is given. Okay. We know, right, how to convert from set builder to roster. We have learned in the previous video. So this means what? X belongs to integers, right? And what is given? X is less than 10. We have to know, is this a finite or infinite set? The first two types of sets are here, as you can see. Let us discuss about them. What is a finite set? Suppose I tell the set of first 5 natural numbers. What is it? 1, 2, 3, 4, 5. So 5 numbers are there, but what if I tell the set of natural numbers? It can be unlimited. So limited set of numbers, that is a finite set, and a set which has unlimited elements, that is infinite set. Just the name suggests here. Let's see for this question what will be the case. We have x belongs to z, that means x belongs to integers and it is less than 10. Now guys, tell me, less than 10, how many integers are there? Means 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And in minus, how many integers are there? We can't calculate. What does it mean? It is infinite. It has unlimited elements. Doesn't this look like a equal to dot 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 dot? Then I put minus 1, 0, 1 dot 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 and up to 10. Just like that. It's unlimited in the negative side. Well, inside. Actually, this is an infinite set, right? Therefore, the answer of this question will be, it is an infinite set. But suppose the question here was given x belongs to natural numbers and x less than 10. Then the answer will be 1 to 9. We have a definite set of numbers. It is limited. Then that would have been finite set. Same if it was given here whole numbers. Okay, understood. But here it is integers. In the negative side it is unlimited integers less than 10. Therefore it will be an infinite set. Understood? These are the first two types of set we came across. Let's do a few more sums on these so that we can get better understanding. Let's see. Question 2 now. Another set we have, it is given the name B. B equal to x such that x belongs to whole numbers. Okay. Comma 5x minus 3 less than equal to 20. Alright. This is a finite or infinite set? We have to find this. Okay. So guys, 5x minus 3 is less than equal to 20, right? So this is a set for whole numbers. So if I take 0 as the first whole number, what does it become? For 0, 5 into 0 minus 3. which is equal to minus 3. Minus 3 is less than 20. It's supporting the equation, but this is the correct value. For 1, we equal to 5 into 1 minus 3 equal to 2. Less than 20, it is the correct value. For 2, it will be equal to 5 into 2 minus 3 equal to 7. This is also possible as it is less than 20. For 3, will be equal to 5 into 3 minus 3. 15 minus 3 equal to 12. Again less than 20, it is possible. Keep checking. For 4, so it will equal to 5 into 4 minus 3 equal to 17. This is also possible. But now if I take 5, this is what? 5 into 5 minus 3 equal to 22. Less than equal to 20, that means the numbers less than 20 and equal to 20. But this is 22, it is greater than 20. Therefore this will be not possible. So what are the values that support this equation for whole numbers? 0, 1, 2, 3, 4. Less than 0 we don't have whole numbers, and more than 4 the whole numbers. They are not less than equal to 20 on doing this equation. Okay. Therefore what are the values that support the equation? Therefore B will be equal to 0, 1, 2, 3, 4. And carefully see, this is a definite unit. It's not unlimited. So this is a finite set. Understood what is the concept of finite and infinite? Check if it is unlimited in any of the negative side or the positive side, or both the sides, it can also be the case. Then it is infinite. If on both the sides there is a means ending, there is a finite set. That's the basic concept. Nothing else. Let's see question 3 now, and then we will move into our next type of set. Many types of sets are there. It will be very interesting to see what are they. Question 3 now. We have been given with a set M. Okay, M. What is it? R such that R equal to 3 by N, I think. Yeah. Okay guys, don't think that always this has to be X. This X, R, A, B, everything are same. Okay. It's just a value, variable, nothing else. And N belongs to whole numbers. Alright. 6 less than N less than equal to 15. Is this a finite or infinite set? Now guys, you can do by just keep checking it. Okay. And you will see, just put one after the other values. Here we have 6 less than N, means N greater than 6 and N less than equal to 15. Then what are the values? For 6, N greater than 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and it keeps going on, endless, can be calculated. Here what is it? Less than equal to 15. Means dot 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 dot, I can just do like that. 7, 8, 9, 10. I guys, this is intentional. I am intentionally writing these values so that I can match them. See, I could have written here 8, 9, 10, but 7 could be omitted. You can guess from it, but it's better to write it in directly in the set. So 14 and 15 less than equal to means 15 should be included. So now what are the common values here? These values 7, 8, 9, 10, 11, 12, 13, 14, 15, and here also the same. Okay. Now you could just be putting one after the values. By 3 divided by 7, 3 divided by 8, 3 divided by 9. Okay. N is a whole number. These all are whole numbers. Alright. But to directly see if it is a finite or infinite set, I am telling you one thing. See, this N is enclosed within a range. Okay. If it was N greater than 6, then it was means beyond 6, unlimited. But N is greater than 6 and less than equal to 15. Okay, that means it's in a range. Whenever you see any numbers in the range, understand that it is a finite set. If you do by the long calculation here, you can get the answer. You will get the set as 3 by 7, 3 by 8, 3 by 9 means 1 by 3, and like that up to 15. That will be a finite set. But see, n is already within a range. So you can directly write here as n is in a range. Therefore, n is a finite set. This is very means carefully remember this. Whenever you see, don't go for long calculation. The beginning see if it has a range or not. If it has n greater than 6, then you have to just do the long process. Sometimes it happens that n greater than 6, you can directly say it's an infinite set. But then do the long process. But if you see that n is enclosed within some range, 6 to 15, yes, 6 to 15 is the range, then mention it as a finite set directly. That's a tip for you. That was a good sum. We learned a new trick. Let's proceed to the next type of sets. So finite sets and infinite sets are completed. Let's see now what we have. We have the set of points of intersection of two non-parallel lines. Parallel lines, parallel straight lines, actually non-parallel straight lines in the same plane. We have been asked, is this a singleton set or not? Okay, I will explain what is it. So now, like the name suggests, singleton means single. That means the set which has only one element in it, that is a singleton set. Remember this. So means if the set is given, the set of an even prime number 2, that is a singleton set. Just like that. Let's see here. We have that a set of point of intersection of two non-parallel straight lines, means on in the same plane. Suppose I am just drawing here, this is a plane. Okay, this is a plane, suppose. Okay, now two non-parallel straight lines. Parallel means what? Like this. Non-parallel means it can mean any way. It can be like this. It can mean any direction. So if I just draw two non-parallel lines like this, so see, do they have 2 points of intersection anyhow? It can't be, right? Even if I draw like this is non-parallel. At some point they will go and meet. They will not meet twice or thrice. They will meet only once. So what does this mean? The set two non-parallel lines in the same plane meet only at one point. Okay. So therefore, therefore as only one point of intersection is there, only one element is there. Therefore, this is a singleton set. Understood? A set which has only one element. That's it. And we saw here any two non-parallel lines in any direction, they only meet at one point. They don't meet twice or thrice. Two parallel lines, they never meet. Okay, remember that. So that's how we got to the answer of this question. Let's see a few more sums on singleton set. Then we will proceed to our next type. This chapter is there in every class, in higher classes, and in 6, 7, 8, 9, all the classes it is there. So learning about it, it is very important for us. Okay. So now question 5. We have with us a set B equal to y such that 2y plus 1 less than 3. Y belongs to whole number. That means any the y numbers of y belong to whole number set. Okay. Means any number whole number multiplied by 2 plus 1 should be less than 3. What is the first whole number? 0. Let's try. 2 into 0 plus 1 equal to 1, which is less than 3. Now if I put 2 into 1 plus 1, that is equal to 3, which is not less than 3 but equal to 3. We have been not given a less than equal to. And like this 2, 3, everything will be greater than 3. That is not possible. So which is the only whole number that supports this equation? 0. So I can write it b equal to 0. Okay, we have to know what is this a singleton set or not? Set or not? Okay. This is the question of the actually topic of the question. So b has only one element, the whole number 0, which supports the equation, and we know a set that has only one element, that is a singleton set. Therefore, b is a singleton set. Easy, just figure it out, see how many elements are there. If more than one, not a singleton set. If only one, it is a singleton set. Now you will be asking, what if no elements are there? That we are coming to very soon. That's another type of set actually. Question 6. And we have come to that part, which many of you might be thinking now. What if a set has no elements? So I have a set A equal to x such that x belongs to natural numbers, comma 5 less than x less than 6. Is this an empty set or not? We have to check if it's an empty set or not. By the name only you can understand what can be empty set. A set which has no elements, that is an empty set, and it is denoted by this sign. It's called null. Null set. Empty set is also called a null set actually. So now guys tell me, so we have here two things, x is greater than 5, x is less than 6. Is there any natural number greater than 5 and less than 6? No. If it was given to us x belongs to real numbers, then we could have had 5.1, 5.2, 5.3 like that up to 5, 6 we could have had. But natural number, no natural number is between 5 and 6. Therefore, A equal to is a empty set. This means empty, okay. We don't have any element here. And what if we don't have any element? It's an empty set, very easy. Therefore, A equal to empty set. Very easy. See, it's not possible actually. Any natural number between 5 and 6. It is according to the question. So, we got the answer accordingly. Another type of set we came across. Let's see a few more sums on this. Actually, this is a really tricky type of set. In the next things that we will learn in the next video, like power set, universal set, we will come across this in various forms to understand the value of this set. It says it is empty, but it is not according to the chapter. Okay. Question 7 now. I have a set B which has x such that x square plus 4 equal to 0. X belongs to whole numbers. So we have to check, is this an empty set or not? Now let's see. This video of today is actually about checking if this is a set, this set or not. Yes or no, that's the main part of this video. So let's see. We are beginning with whole numbers. So what is the first whole number? 0. 0 square plus 4 is 4, which is not equal to 0. 1 square plus 4 equal to 5, not equal to 0. And like this it will keep going on, and it will be means endless. 2 square, 4 plus 4 8, and it will keep going increasing. So no whole number square plus 4 is equal to 0. We got the value. If it was here, it was given to us integers. Okay, then only we could have got the answer, and it could have been a singleton set. How? The integer minus 2. Okay, no, actually then we couldn't have got the set, because let's see, minus 2 square, that is 4 plus 4, it is 8, so that is also not possible. So this is completely impossible. This is an empty set. No whole number square plus 4 is equal to 0. Okay, therefore this could have been minus, then the case should be something else. No need, the question doesn't say that. Therefore b equal to empty set. So b equal to empty. Now you will be asking, sir, why are you writing b equal to this first empty set symbol and then writing b equal to empty set in alphabets? For your convenience, but you can just write the first part only, b equal to this 2 second brackets, within that nothing. That's also correct. No need. Let's see question 8. Okay, now a little bit new things. So I have two sets now. A equal to 4, 5, 6, 4, 5, 6. And another set b equal to x such that x square minus 5x minus 6 equal to 0. We have been asked, are they disjoint or not? Are they disjoint sets or not? Let's understand. Now a new term is disjoint. So suppose I have two sets. Let me write it like this for you. A equal to ABC and B equal to DEF. The condition is that no element of A should be equal to any element of B, and no element of B should be equal to element of A. Okay, means all the elements of both the sets should be different. And in the case of joint sets, the other case comes. If the sets means, if there are two sets, at least one element should be common among them. Like an ABC, then AEF, then one element A is common among them. Therefore, that is a joint set. It can be two elements or all the elements are common. Then that is also a joint set. But at least one element needs to be common for it to be a joint set. Okay. And disjoint set means in the two sets, no element is common. Okay. So let us check if anything is common among these two. What do they have for us? A equal to 4, 5, 6. Let that it be as it is. For B, we need to solve this quadratic equation. B equal to what? Okay, let's solve it here. X square minus 5x minus 6 equal to 0. Now let us see how we can make minus 6. We have done that. 1 into minus 6, 2 into minus 3. Okay, there we go. 1 into minus 6, it is minus 6. The product of minus 6 and here 1. And 1 minus 6 is minus 5. The coefficient of x in the middle term. Okay. So I can write this as equal to x square plus x minus 6x minus 6 equal to 0. Or x into x plus 1 minus 6 into x plus 1 equal to 0. Or x minus 6 into x plus 1 equal to 0. Now x minus 6 is equal to 0 and x plus 1 is equal to 0. X minus 6 equal to 0 means x equal to 6 and another value is x plus 1 equal to 0. So x will be equal to minus 1. So what is the set B? b equal to 6 comma minus 1. Okay, we got the sets A and B. Now let's see. See guys, in A and B, one element is common. It is 6. And I told you for joint sets only one element should be common in both the sets. One or more than one. But in disjoint sets, no element can be common among the two sets. Okay. So A and B are not disjoint sets. Understood? We have to see if an element is common or not. If yes, the joint sets. If no, disjoint sets. That's the main topic about these sets of disjoint and joint. Let's see what we have now. So let's see question 9. Now we have A equal to B, C, D, E. Letters, no numbers. In sets we tell them as elements actually. And in B we have X such that X is a letter in the word master. Master. Okay. Now we have been asked, are they joint sets? Yes or no? Okay. So A is already given. A equal to B, C, D. We have the elements in roster form. For B, it is a letter in the word master. First, let us check if master has any two same letters. No, all are different, right? So what will be the set B? B equal to master. Okay, a very interesting part is here. And now see, A is small b, small c, small d, small e. Now you will be saying E is common among them. This is a joint set. Carefully see this. E is here small, E is here large. In the means language of sets, the case doesn't matter. It can be uppercase or lowercase. If it is different the case, then the means elements are different actually. So small e and capital E are different in the version of sets. Okay. Now let's check if any other element is common. B is not here, C is also not here, D is also not here, and E is there but small e and here capital E. So E is also not here. So no, this is not a joint set as no element is common among A and B. Therefore A and B are not joint sets. Don't write that disjoint sets because the question is given, are they joint sets, yes or no. Write like that, okay. That's another question, a little tricky because of this E only, nothing else. If it was given like this, MAST, then small e and capital R, then it could have been a joint set because E is common. Okay, but not the case here. Alright, so question 9 is completed. Let's see a few more. Now question 10. Now we have a new type of a set. Okay, let's see what is it. So I have A is equal to what? X such that X belongs to a natural number, comma 11 greater than equal to 2x minus 1. Okay. And another set I also have B equal to what? Y such that Y belongs to whole numbers. Okay. And 3 less than equal to y less than equal to 9. They are asking, check if it is a equivalent set, if these are equivalent sets or not. Okay. Let me explain to you what is equivalent. If two sets A and B have the same number of elements, suppose A has 3 elements, B has also 3 elements, then they are said to be equivalent sets. If the number of elements in A and B are not same, then they are not equivalent sets. Let's check what elements A has. So X belongs to natural number. Okay. X, as that X belongs to natural number. This is some mistake is there. Okay. So X belongs to natural number. Let us see. So 11 less than equal to 2x minus 1. Okay. So let us check for the first natural number is 1. So 2x minus 1 means 2 into 1 minus 1. Okay, let me write it properly for you. 11 greater than equal to 2x minus 1 means 2x minus 1 less than equal to 11. A, for this we are A doing here. Now, what I have? 1. So 2 into 1 minus 1 is equal to 1. 1 is less than 11. It supports the equation. For 2 I have 2 into 2 minus 1 equal to 3. This also is supported by the equation here. 2 into 3 minus 1 equal to 5. This is also possible. It is less than 11. Here, I just converted it for your convenience only. It should be less than 11 or equal to 11. 2 into 4 minus 1 equal to 7. That is also possible. 2 into 5 minus 1 equal to 9. This is also possible. It is less than 11. 2 into 6 minus 1 equal to 11. That is also possible, as it is equal to 11. That is also possible. But after 2 into 7 minus 1, this becomes 13. 13 is greater than 11, which is not possible here. It should be less than or equal to 11. So this is not possible. After this also not possible, but these are all correct. Got it? So what are the possible values for A then? 1, 3, 5, 7, 9. Therefore A equal to 1, 3, 5, 7, 9. Now let's proceed to B. For B I have 3 less than equal to y less than equal to 9. So I have two equations, which is y greater than equal to 3, y less than equal to 9. So let's check the values. Okay, for y greater than equal to 3, just converting here. 3 less than equal to y means y greater than equal to 3. Now let's write, this is 3, 4, 5, 6, 7, 8, 9, 10. Keeps going on, it is endless. Greater than equal to. Less than equal to 9 means dot. Okay, so y is this whole number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so no, this is not endless. Whole number, right? So this will be 0 to 9. Okay. So you have to find the common elements now among these. What are they? 3, 4, 5, 6, 7, 8, 9. Yes, of course. So these are the common elements. So then what is the set B? B equal to 3, 4, 5, 6, 7, 8, 9. Alright. Now let us see what we have here. A has 5 elements, B has 7 elements. So, and what do we know? Number of elements of a set means cardinal number of A, which is written as Na. So Na not equal to Nb. Therefore, A and B are not equivalent sets. Okay. Understood? First we have converted the sign, got the values, and then checked for every value of natural number and we got that up to this, to 1 2 3 4 5 6 we are getting the values. Okay, so one thing here, this should be okay, I think I shouldn't be not right here. This will be 1 2 3 4 5 6. 7 is not possible because that will be greater than 11. That is not possible, right? And here we have y is greater than equal to 3. Means 3, 4, 5, 6, 7, 8, 9, 10, it goes on. And here for whole numbers it is less than equal to 9. Means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I have 7 digits common. Okay. So B has 7 elements but A has 6 elements. So cardinal number of A not equal to cardinal number of B. And remember that if cardinal number of A equal to cardinal number of B, then those are equivalent sets. Not to be the case here, therefore these are not equivalent sets. That's how we solve this question. Very easy. Just a little bit long process, but topic is actually easy. You have to just check if both the sets have same number of elements or not. Let's see a few more questions. Okay. Now I have set of integers and set of natural numbers. Set of integers set of natural numbers. So they are telling that are they equivalent or not? Here we have a good theory actually. See guys, set of integers. So it's an infinite set. It has unlimited elements, and natural numbers, it is also infinite set. So remember, when you are told that find for two sets which are infinite sets if they are equivalent or not, they are equivalent. Two infinite sets are always equivalent. That is the main principle. Always remember this. Two infinite sets are always equivalent because we don't know how many elements they will end up with. So that is beyond the concern of us actually, if you just know this statement. Got it? Therefore, set of integers and set of natural numbers are equivalent. So keep this in mind. Okay, these are questions may come. So also consider of whole numbers and set of natural numbers. Same case, both are infinite, for they are equivalent sets. Remember this. Okay. Now let's proceed to our next sum. We learned this theory. Keep this in mind. So then question 12. I have here A equal to 2468 and B equal to 2n. N belongs to natural number and n less than 5. Okay. They are asking, check if it's equal sets or not. Check if they are equal sets or not. Alright. So what are equal sets? Equal sets are if two sets have the same elements, like A has 1 3 5, B has 1 3 5. They are equal sets. It can also be like this: A has 1 3 5, B has 3 5 1. Suppose this is an example. Okay. And see, the elements are same, they are arranged in a different order. These are equal sets. When the elements are same, they're equal sets. Okay. So we have to see if these two are equal sets or not. Equal sets actually are a type of joint sets, because we know the case for joint sets, the elements have to be common. It can be one or more than one. So all the elements can also be same. That is also a case for equal sets here. Keep that in mind. Let's proceed with our sum. We have A equal to 2, 4, 6, 8. Keep this as it is. We have B equal to 2 into n. We have to multiply every n number of n by 2. N belongs to natural number, n less than 5. What are the natural numbers less than 5? That are 1, 2, 3, 4. And 2 into n, therefore what will be the set B? B will be what? 2 into 1, 2. 2 into 2, 4. 2 into 3, 6. 2 into 4, 8. Okay. Now I see all the elements here 2 and 2, 4 and 4, 6 and 6, 8 and 8. All the elements in A and B are same, and we know that all the elements in both the sets are same, they are equal sets. Therefore, A equal to B or B equal to A. Right? Or this looks like divide, I know. Or B equal to A. That's the answer. We checked actually what are the elements, and if they are same or not. They are same, so they are equal. Very easy. Let's see the next type of sum. So now I have another one. You have to check if it is equal or not. So that is, I have a set n which is x such that x belongs to whole numbers, comma x plus 3 less than 8. Okay. I also have a set n which is given by y such that y equal to 2n minus 1. N belongs to natural numbers, comma n is less than 5. We have to check, is m equal to n? Yes or no? Okay. Means just we have to check if they are equal or not. Let's first find the elements of m. So x belongs to whole number. Let's check for m. I am writing for m here. 0 plus 3 equal to 3, less than 8 supported. 1 plus 3 equal to 4, less than 8 supported. 2 plus 3 equal to 5, it is also supported. 3 plus 3 equal to 6, less than 8 supported. 4 plus 3 equal to 7, that is also okay. But 5 plus 3, it is equal to 8, that is equal to it actually here. Not to be the case, it should be less than 8, this sum. So what are the values possible? These are possible. But after this 5, 6, 7, 8 all are cancelled. So then what is the set m? The values of x here. So we have for m equal to 0, 1, 2, 3, 4, 5. Alright. Now for n, let's solve for n. N I have y equal to 2n minus 1. N belongs to natural number, n is less than 5. What are the natural numbers less than 5? 1, 2, 3, 4. Now according to the question, to get y's values, we have to multiply each number of n by this 2 minus 1. For y, the values which are 2 into 1 minus 1, 2 into 2 minus 1, 2 into 3 minus 1, 2 into 4 minus 1. Right, 2 into n minus 1, the values of n. This is equal to 1, this is equal to 3, this is equal to 5, this is equal to 7. 4 minus 1 is 7. Okay. Now let us see what is the set n then. N is 1, 3, 5, 7. Got it? Therefore n equal to 1, 5, 7. Okay. See, we found out the sets just using the equations. This is supportive, all these are supportive, but that's not, it is equal to it, not possible. Got the elements? Okay. See this. 5 is not possible. This should not be written. Up to 4 it is possible as it is less than 7, 8, the sum. But this, it becomes equal to 8, not possible. And here what is the case? All these numbers multiplied by 2 minus 1 to get the values of y, which are 1, 3, 5 and 7. Okay, now let's see which elements are common. So 1 is common among them, 3 is common, but 0, 2 and 4 and 5 and 7 are uncommon elements in both the sets. And for us two sets to be equal, all the elements should be common. Yes, this is a disjoint set because among the two sets, any one element or more than one element is common, but not equal, as not all the elements are common. Therefore, m not equal to n. This is not equal to. That's one more type of sum. You have to come across answers of both yes and no. So don't think that it is no, that is I am wrong. No, it can be no anywhere. Like if you have MCQs and the last answer is not possible, you always have to eliminate it. No, many times that is also the answer. Watch it carefully. So now, question 14. We are almost towards the end. I've learned all the types of sets actually. Few more sums. I have here again two sets. I have E equal to x such that x square plus 8x minus 9 equal to 0. And I have f equal to 1 comma minus 9. Okay. I have to check are they equal or not. Is E equal to f? Yes or no. All the sums are dealing with yes or no only. That's different type of sets. That's it. That's this chapter. That's why it is types of sets. Okay. You need to focus on that only. So let's find out E. So we have for E, I am writing here, I have to solve this quadratic equation. So let's solve it here. Square plus 8x minus 9 equal to 0. Let's see how we can make minus 9. 9 into minus 1 it is possible, 3 into minus 2 it is possible, and 1 into minus 9 is possible. Okay. Now let's see. 9 minus 1 it is 8. The coefficient of x is the middle term. And 9 into minus 1 is minus 9, which is minus 9 into 1 here. Okay. So what can I write this as? Equal to or x square plus 9x minus x minus 9 equal to 0. Or x into x plus 9 minus 1 into x plus 9 equal to 0. Or x minus 1 into x plus 9 equal to 0. So x minus 1 equal to 0, that means x equal to 1. Also x plus 9 equal to 0, that means x equal to minus 9. So what is the set E then? E equal to 1 comma minus 9. Okay, sorry. And we have f. F is 1 comma minus 9. For equal sets, all the elements have to be equal, same in both the sets, in all the sets. So here we have all the elements equal. Therefore, E equal to f. We got the answer. We solved the quadratic equation like that. As you can see, we found out how minus 9 is possible. Got 9 into minus 1 and solved the equation accordingly. And got 1 and minus 9 as the values for x or the values for E. And now we have all the elements are same. Therefore, E equal to f. Very easy. So then, now let's proceed to the last sum for today. Wow, we did so many types of sets. The types of sums were same actually, but we learned many things. And that principle, if two sets are infinite, they are equal. Okay. But then the last question for today, this is a little bit easy sum. We already have learned this principle before. If NP equal to NM, is P equivalent to M? No, sorry. P equivalent to M, we have to write, is this true or false? Okay. Have to see if it is true or false. Okay. So NP means what? The number of elements of a set. The set P. That is equal to the number of elements of the set M. NP means cardinal number of P and M means cardinal number of M. Cardinal number means the number of elements of a set. That means if the number of elements in P equal to number of elements of M, is P equivalent to M? You have already learned that if both two sets have the same number of elements, they are equivalent. Therefore, or that can be said as if the two sets have the same cardinal number, that is equal to equivalent, they are equivalent. So in this case also, as both the sets have the same number of elements, so P is equivalent to M. Therefore, 2 is the correct answer. Understood? Remember this principle as well. If both the sets have the same cardinal number, if Na equal to Nb, then A is equivalent to B. Understood? So with that, we have come to the end of this second part of sets. Understanding different types of sets, doing a lot of sums. And now we are left only with the last part, the different functions of set. We'll do a lot of functions which will include the disjoint sets and joint sets or overlapping sets. You will see what is that. Why didn't I say overlapping here and here there? That will be overlapping. So with that, part 2 is completed, types of sets is completed. The next video of part 3, I will be coming with the functions of sets, all the operations. So stay tuned for that video. If you found my video of part 2 for sets informative and helpful, please like, share and subscribe my channel. It means a lot to me. With a lot of love from my side. Till my next video, take care and goodbye. Thank you.